Holdea, which is I guess CB will correct me here, but a graphical user interface for logical relations. Is that fair?
Yeah, yeah,
All right, great. Well, take it away.
great. Yeah, thanks for having me. Um, just have a few slides as an introduction. So try to share. Okay, second. Hi, my name is CB, also Christian. I was Christian Williams and then got married recently. Um, so yes, I'm going to be presenting a visual logic interface that I've been developing over the past several months, and I'm excited to share. Um, so I completed my PhD at UC Riverside with John Baez and Mike Schulman. And it was about, it was in category theory, but it defined a three-dimensional visual language where kind of the big light bulb moment was realizing that the third dimension visually is inner to outer. So you can represent transformations between things by nesting nodes inside of each other. Um, I'll show examples of that. But that part is like the most advanced. So it's the least developed so far in the interface. It's just like the little beginnings of it in the interface. So I graduated and I was excited to make education materials based on this visual language, but it was slow, especially because there is not any general kind of dedicated software for these kind of node and wire diagrams. So it was hard to produce um, a lot of education materials. So I had a brief job at Connexus. I don't know if anyone here, probably a few of you have heard of it, this category theory and database company. And they gave me a little bit of freedom to work on my own stuff. And it was through conversations with them that I realized that visual logic is also a query. It could also be a query tool. Um, and more generally, I realized that you could make visual logic into a knowledge interface that you could use for education, but also as a data tool for science, for all kinds of research or industry. So I realized, oh wow, like this really needs to be done, and that was about a year ago. Um, I hadn't done much coding. Last year, I met a potential partner, and I was thinking that uh, I would need all the help I could get. And we got along well, but ultimately had different priorities, and that's all right. And the past maybe 4 to 6 months, I've been developing this on my own. And it's been quite a crash course in a lot of stuff. But luckily nowadays, it's could be it surprisingly easy to learn coding. There's a lot of resources now that make it a lot easier. And so um, it has been coming together well. And the first version is almost ready to launch. And I'm aiming for it to be ready by ACT 2025 in June. And I think in general that visual logic can empower people, and I'm excited for this to become a shared endeavor. Any quick thoughts or questions about any of that. So, so I think the core ideas of visual logic are extremely simple, or that core ideas of logic in general, I think, are extremely simple. That everything is some type of thing, and every thought is some relation of types of things. So, for example, every sentence that you're saying expresses some predicate of some things. And it's, I think it's so basic that we forget sometimes, but it's something that you could do by yourself or with anyone. You could literally take turns thinking of anything, noticing anything, and you just express it. And then you can identify, okay, what were the things involved in that statement? And then what was the predicate of them? And I think that perspective sounds very simple, but is very kind of unifying and enlightening. So the idea is that we can see a relation as a node that connects ports. So for example, the relation of friendship here would connect one person to another. And it could also connect some other extra information, such as what those two friends share, for example. Can connect any number of things. It could even just connect one thing. It doesn't need to be multiple, and then people usually call it a predicate. And this has been, I think, discussed by Nathan and others in the group. This basic idea of relations as connections was first explored by C.S. Peirce in the 1800s, and then wasn't fully appreciated for a while and is now making a comeback, which is good to see. And so it's the language that I'm working on is very close to, it's almost exactly the same as that one, but just with some slight differences with the nesting, the 3D aspect. And then, yeah.
We have one question just to clarify. What's the difference between the colored circles there?
Yes, yeah. So color you can use to represent types, as in here, green could represent the type of a person, or maybe it represents the type of string or word, the actual data type that you're writing a person's name. And then here, blue could be whatever type you're representing for what they share. So you can use these for basic data types like string or int or float or Boolean, but you could also use them for all kinds of types. So like lists or products, or the way that you build up more complex types to store richer information. Yeah.
I think Priya has a follow-up question here, but Priya, do you want to just state it, or so she says, so no two different types are allowed the same colors.
Yeah,
is that the case? Yeah, okay.
It's like it's a way we distinguish. Like you can do a color-free version if you like wanted to label the types, but you just need some information to distinguish the types, because you can only connect ports of the same type, because the connections by wires are going to be equalities between variables. So it wouldn't make sense if they're of different types.
Okay, thanks.
Yeah.
Oops. Also happy for the Peirce reference. great.
Yeah, yeah, and yeah, Nathan prompted me to think about what does compassionate mathematics mean to me, and after thinking about it a bit, or like how it relates to what I'm doing, I think that a basic and important form of compassion is to affirm one's thoughts are real and helping to express the thoughts. So compassion either to yourself or among each other, being able to affirm that we're each having our own real experiences and be able to express them in a way that brings them out into the open, makes it less intimidating and allows the person to reflect on the ideas and build upon them. I think that right now in early education or most education, we're only giving children and students symbols to represent their ideas. And when it comes to visualization, it's normally limited to drawing like one thing at most, and visualization of complex ideas, of interrelated things, is almost not explored. And this is where I think visual logic can really help students feel like, oh, okay, the world might seem really complicated, but it's made out of simple things, and I can get better at just drawing out those simple things and getting a feel for them. Yeah. So anyway, this is the idea of visual logic, is that relations are connections. That's really all there is to it. So how does this become an interface? How does it become something practical that people actually want to use for different purposes? So a relation in logic is equivalent to a table in a database, where the types being related are columns of the table, and an element of the relation is a row in the table. So here, these three views of friendship are equivalent. The visualization, just the symbol version and the table. And the interface lets you use all three at once, kind of in synchrony. So let's go ahead and jump into an example. Okay, so you can still see the screen. Cool.
Yep.
All right, so this is the interface so far. And the first basic thing is the parts of the interface. So in the center here, you have the canvas for visual logic that's going to have the nodes and wire diagrams. And on the right, you have the equivalent logic symbols view. And then at the bottom here, you have the data view of the actual elements of the relation. So here, Maria is friends with Elena, James is friends with Robert, etc. And you can have any extra information that you want about some relation, like how close they are as friends is just some random information. So those are the three parts, and then this on the left is like your library of relations. So when you make an account, you can upload tables just straight from your computer. Before long, you'll actually be able to connect a whole database, but for now, it's just uploading CSV files. So like another example is projects here. Maybe planning some projects for a community garden is the example I was doing. And from these basic tables, you build more complex things to gain information. So I'm just curious, has anyone used a data tool where you make some searches or queries on some tables to gain some information?
How's that different from a Google search?
Oh, so
How are you
right.
distinguishing data tools from?
Yeah, so on Google or any of the other search engines, most of the time you're only using keywords, and all that it's able to do is match keywords to their occurrences in web pages. So in a certain sense, it is a query tool, but it's a very limited one. You're not able to say, show all Wikipedia pages that satisfy this complicated condition, that, mention this person in context with this person, etc. Google has some limited support for
Would
regular
that be
expression.
doable by modern AI type tools? Is that something that's that is not available to things like Claude and ChatGPT and so forth?
So
So when I ask a
the main
data,
thing,
I'm not sure which data tool you're talking about. That's all. I've
oh,
used Excel.
I,
I've used Excel. I've used Google Sheets. I don't know what data tool you're talking about other than the things pretty much everybody knows about. So
yeah, Excel, I guess is pretty similar. I guess I was thinking about like SQL tools where you had
okay.
a bunch of tables, and then you wrote out a query that might join some tables together, but you can kind of do some of that in Excel as well. Um,
Yeah.
yeah.
We have
I was just wondering how I would answer your question, and I couldn't answer it because I didn't know what you were asking exactly.
yeah, it's kind of a general question. Yeah.
we have another question from YouTube. So thanks, Nils. Can this be done with Boolean circuits? If not, why not?
Yeah, so I don't remember what those are, but I'm sure the answer is yes. All these visual languages are closely related. Sorry. But we could look into that toward the end and compare Boolean circuits to this. Okay, so let's just see a small example of using this. So right now we're only looking at one table, but now let's actually make something new. So you can right click on the canvas and then pull tables in. So let's say you want to know how people can help each other. So you could connect friends to resources. So here, by connecting these two relations with this wire, you're saying make these two variables equal. So in the code here, this just took this graph, this visual information, and automatically converted it into, this is a statement in Prolog. If anyone has heard of Prolog, it's a logic programming language. And basically, this is a logic programming interface. So we need to specify which variables we actually want to look at. So here we want to see person as a friend with some person 2, which is equal to this person. And that second person has access to some resources. So when you select those variables and generate again, now you're going to be selecting those here. And now we could run this and it pulls up the results at the bottom. So now this is not just showing one table, but now it's computing and finding these connections of a friendship and that second person having access to some resource. So in normal like data tool terminology, this would be inner join of one table along, of two tables along some shared column here. But in logic, it would be just taking the conjunction of these relations and then matching on this middle variable, composing relations along this variable. Any thoughts or questions about this? So right now, it's being left implicit, but to fully represent this, you would nest that composite in another node that you would name, you would give this query a name. So let's say you call it friend has, then you would nest this composite relation in friend has to express if this inner relation is true, then make this outer relation true. So pretty soon when this interface is fully developed, this nesting will be fully supported so that you could then take this more complex thing that you built and then collapse it to just the outer node. And then you're like zooming out and building something out of that. Or vice versa, if you have something that's built out of complicated things, you could expand, if you forgot what one of them means, you could expand it and explore code in that way. But like I said, the 3D aspect is not fully there yet, but this is the idea. It's that nesting just means if the inner stuff is true, then make the outer relation true. So that is where this interface goes beyond what currently exists. This basic idea of nodes with ports and connections, there are several existing data tools that do fairly similar things. So for example, there's this Tableau tool where you drag tables into a canvas, and then you can take their intersection or union here, for example. But notice this one, it doesn't actually show you which columns you're intersecting along. It just shows that you are intersecting along some columns. There are some that show a little bit more detail, but that's about as far as I've seen that these visualizations go. They give you a little taste of visual logic, but not the whole thing. And the main differences are this nesting to represent rules, and also negation. So this part I haven't mentioned yet. So far we've just seen relations and composition, and that is the half of logic called regular logic, which is built out of conjunction and existential. But to get all of first order logic, you also need negation. So here we can, in visual logic, we can represent negation by wrapping a relation in an opposite background color. So here, this represents, we have a table of restaurants in the local area, and then you're keeping your own table of your visits to restaurants. And you want to express, you want to search for restaurants that you have not been to yet. So the way you represent that is just wrapping the visits in this, this gray here. And if you're in light mode, it's still gray. If you're in dark mode, it's gray. You can still distinguish it. And so in logical symbols, what does this do? It says show. This says show local restaurants, such that it's not in my visits. And we want to actually select some information from that. So let's say name, and let's get the basic information from the restaurant. And now this finds the ones you haven't been to yet. So this is all restaurants. My visits, you've been to 1, 2, 5, and 7. So you've been to Best Thai, Thai Orchid, Green Garden, and Thai Chef. And so this query finds the rest.
CB, we have another question from YouTube. Is this Holdea tool publicly available?
Soon. So in the next month. It is going to be at holdea.net. Yeah. So this idea of negation is not new. C.S. Peirce represented negation by surrounding a relation in was it just by circling? It was just surrounding in a solid line,
circle.
Right?
Yeah, he called it a cut, or a sep line, short for separation. So he was just separating it from the broader sheet that you're writing relations on.
Yeah, so this isn't new, but it just isn't well known yet. And so these data tools don't have that. So they're not able to visualize negation. So you're missing this whole other half of logic.
But
Yes.
so what I'm sorry, what what is the difference between classical negation and this negation? Is there a difference?
No, this is meant to be classical negation. Yeah.
Okay. And so it's not negation as failure as in prolog?
No, yeah. So well, in visual logic, it's meant to represent classical negation. This interface is, at least the first version is based on prolog. And so it's going to implement it as negation as failure. Yeah. So it's just slightly different, and I'm still getting a feel for the subtleties there. But basically, you prove not just if you can't find a solution.
Right.
So
but so when you say classical or earlier when you said first order logic and you said we don't have negation and so it's not all of first order logic, I found that interesting because our friends in intuitionistic and constructive reasoning and so forth deny the law of the excluded middle, which means that negation as they view it is different from classical logic. So it's different. It's not negation as failure. It's more strict. It's a sort of a more strict version of negation than classical logic. You have to do a constructive proof of a negation rather than a by contradiction. You can, actually, you can prove a negation by contradiction, but you can't prove a statement by proof by contradiction using the negation. That's one of the subtleties. Thank you.
okay, so just real quick, I want to show a couple more that help to drive the point home that visual logic can pretty quickly start to do things that no existing data tool can visualize. So one example is recursive queries. So for example, let's say you have a table of parenthood relationships and you want to use it to construct a whole family tree. Then you just need two rules. If person one is a parent of person two, then person one is an ancestor of person two. So that just pulls in all the parents. And then also, sometimes there's an issue with edges. And then what is the recursive part? Well, if A is a parent of B and B is an ancestor of C, then A is an ancestor of C. So from these two, the logic engine is going to go generate all possible ancestors. And so each of these rules, when you execute them on their own, will show, like this would just show direct parent relationships, and this one would just show grandparent and more, great grandparent, etc. But then when you just want to, once you've made both rules, you just want to query the whole thing to find all ancestor relations. Then then it goes and adds them all together. And let's see if this works. Yes, so it found 97 parent and grandparent and great-grandparent relationships. So right now, because data tools don't have a way of expressing rules, they can't express this recursive thing. And so you would have to go into some SQL editor and do some kind of union-all thing. It's just a lot more complicated. But anyway, so this is an example of how you can make one relation that is built out of multiple rules. So this symbol here, soon when you click it, it's going to expand into like the first rule, and then there will be tabs that you can cycle through. So you can make some complicated relationship, and whenever you forget its definition, you can expand it and cycle through all of the ways of making that relationship. And finally, last example that is.
So just a quick question on that last one. So
yeah.
that ancestor, that was coming from what you showed us before, where you made a box that had kind of a composite relation inside of it.
Mm-hmm.
Okay, and then those little arrows that you would show, they would let you kind of zoom in and see what that inner relation looks like.
Yeah.
Okay.
So like if you you make this and you save it, and then it's going to automatically make this outer box, which you could then collapse out, and it's like you're zooming out to ancestor, and then you could press it again and re-expand to see its different definitions.
Neat. Okay. Just a question about it. Was there any like what's the theory behind that? Like, did you have to add something to it to allow for that functionality, or was this like, is the box, what's happening with the box that allows us to do that?
Well, the idea is that that this nesting represents entailment between relations. And so I'm not sure what your question is. Are you saying that like
So
when you're
in the first example that you showed, where you had just composition, right? And you can form a box around it and then think of it as like a larger composite relation. But this seems to be a little bit differently, or a bit different, because it maybe does capture an entailment, as you said. And so I wondered if there was more going on, and I think this entailment probably is the additional thing that's going on.
Yeah.
Okay.
Yeah. It represents entailments. Yeah, and then let me just show a quick last example, and then I want to hear y'all's thoughts and just open up for discussion. So this last one is something that would be quite a bit more complicated to try to write out in code, but I think personally, I think it is pretty simple in visualization. So what this means, you have a table of projects. Here's a table of potential projects for some community garden. And you want to, each of those projects has requirements of all the resources that you'll need. And you have a certain inventory right now. So you want to make sure that you have enough of everything. So the way to read this is show all projects so that there is not any requirement which does not have enough in inventory. So if A, then B is equivalent to you never have A and not B. So this is this cool way that you can use and not to represent other operations like implication. So this is equivalent to like for all requirements there, or yeah, for all requirements there is enough in inventory. So this generates this big complicated thing. Each of those not wrappers becomes a not in logic. And then when you execute this, it computes the projects that have everything ready to go in inventory. And yeah, so this is the kind of thing that you can do in this tool. I think the thing that will be most valuable is that not only can you make complex searches more easy, but also then you can immediately take the results of that search and then start doing something with it. Like actually taking some action in the world, saying, okay, if this project is ready, then go send an email to this person, get this stuff out of the inventory and start, start building it. So it's both a knowledge tool and an action tool. You do both because you can express rules. So yeah, obviously it's still in development, some things to work out, but hopefully in about a month or so, month and a week, it will be online at holdea.net. And I'm just excited for this to be shared. So yeah, thank you, and welcome all thoughts.
Thanks. There was one further question at the end here by Giannis in the chat. Is there a GitHub link to the code, or will there be one eventually, maybe for the visual code?
There will be. There will be. Yeah, this will. I'm still figuring out how to the best way to make a living off of this. I think that you could easily make a ridiculous amount of money with something like this if you actually played your cards right, to be honest, but that's not really the point. And I just want to figure out how to make just enough. And other than that, it's going to be completely open source, completely public. And yeah, so all the source code will be available.
Thanks. Well, we'll open it up to questions. Feel free to just unmute yourself and or raise a hand, and I'll try to get to them in the order that I see them. But we'll start with just unmuting and ask around.
Mm-hmm. So I posted I put something in the chat.
Yeah, that's a good question. So you're asking about the order of relations and whether that affects the computation.
Well, essentially, let's see here. It seems to me like the way that the recursion would work for what you described would be less efficient, because the way Prolog works is it asserts information into a database. And if you already have the ancestor relation between person 1 and person 2 in the database for ancestor, then using this kind of recursive call would not require that Prolog go and look in the parent, recurse all the way back to the parent every time.
Well, if you're computing for the
Maybe
first time,
the implementation. So
if you're computing for the first
all the way.
time, then you don't have the ancestor relation yet.
Because
Well, if you're computing
maybe
for the first time,
the implementation. So
if you're computing for the first time, then you don't have the. Somebody has an echo yet. Well,
I don't know where this echo's coming from.
I guess maybe it resolved itself. So we'll carry on.
But yeah, I could show just a quick like look under the hood. So what's happening is each time that you upload a table or save a new rule, ultimately you're basically just managing one module or file in Prolog. And so this, when you upload a table, it makes this term in Prolog that queries the database and pulls it in, and it's like injecting that that data into Prolog. And one thing about Prolog is that it doesn't keep the types of the arguments, which we often care about. So it is not too hard to just add extra type information about the tables. So these are all the tables, and then when you start saving rules, it's just putting them straight into your module, and this is what you're querying against. And yeah, like as soon as you save it, it calls and like regenerates the whole thing so that you can actually like immediately use something as soon as you define it. That's one of those things that I thought was going to be really hard, but then once you learn enough of the tools, it's not as bad. It's not as hard as it seems.
Just a quick question or comment, I suppose. First of all, congratulations. That was a really nice talk and very impressive. Having worked on similar user interfaces myself, I know how much work it takes to get that off the ground.
Yeah.
So
Thanks.
yeah, very cool. And I guess one of the things that initially wasn't so clear to me about this recursive query with the ancestors, but I think over time it started to make more sense, is that well, I guess what's special about it is that it is recursive, which means that you're referencing the rule inside the rule itself, right? And it's kind of a box that is infinitely deeply nested. Is that kind of one way to describe it? And then so you could keep clicking on this ancestor box over and over and over again.
Exactly. Exactly. Yeah. So once this expanding aspect works, it's going to be really fun to explore dynamically, because yeah, for this ancestor example, you can, as soon as you define ancestor, that makes a really big query with a lot of results, and you probably don't want to see the whole family tree right away. So maybe you start with parents, and then you cycle over to the next rule that says parent of ancestor. And that starts showing grandparents. And yeah, then you expand that ancestor one, and it expands to parent of ancestor. and then it's showing great-grandparents, etc. And yeah, it'll start to literally make this long chain that goes inward.
Mm-hmm.
So
well, one of the things that's interesting about these kinds of recursive queries is that I believe they're related to computing the transitive closure operation, which is something that normal database query languages don't allow you to do typically because of the associated complexity cost. So there is in a way they put safeguards, restrict your ability to do these kinds of queries because there is a danger of having the runtime explode or the data sets become huge.
yeah.
So I wonder whether you've had any thoughts about that and how to manage that in your tool.
That's a good question. Yeah, right now, I'm just working with small examples, so it's not really seeing how complex it can get. That it's honestly a good question. One, I don't really have a good answer so far, honestly, and I could use input on that. One thing is that prolog can be quite a bit slower than databases when it comes to just composition or joins. SQL has been really optimized for that. And so one way that this will improve is recognizing when there are a bunch of joins and turning it, kind of coalescing those and turning that part back into an SQL join should help a lot. But in terms of stuff that's hard even for just SQL databases to do, I don't I don't have the background knowledge to improve on that. So somehow you will need some kind of guardrails. But yeah, that's a good question.
Yeah, it's fair. I think obviously you don't want to compete with like the years and years of engineering that went into optimizing databases. It's probably not a very fruitful endeavor.
Yeah,
I guess one thing that might be interesting to look at are these kind of query languages
you're cutting out for a sec.
that were invented to query, like I forget the name.
We lost you,
News.
Dan. Didn't hear
Yeah,
you.
do you want to repeat that question if you're still there? We missed you for part of it.
It might help if you type it in as well. So
He's plugging something.
Sorry, yeah.
He's good. He's all right. He's good. He's back. All right.
Should be better now. Sorry, I wasn't connected via cable. So I was just saying that I don't know how much you could hear from what I was saying, but there are these other more recent query languages, like I think GraphQL, which were designed for document databases and RESTful APIs, and that might be another interesting direction to explore because I think they do offer some new expressive capabilities to work with more structured data, nested data, and things like that.
Yeah, definitely.
I have a somewhat related question, I think. I don't know, I'm still struggling to fully understand the logical implications of this. But I'm wondering if this environment allows you to make inferences, for example, on a recursively defined object like this, without actually explicitly computing the object. So, because the problem that Daniel was talking about and you were addressing earlier is, of course, the exponential explosion that this might entail, the infinite depth. But it's conceivable that if you wrap it around some other logical requirements or some other aspect, eventually, I mean, you can still make entailments from that that would be finite, that would be small, perhaps, but somehow, so this would be a purely, logical inference without evaluation. Or does the tool imply an evaluation at every step?
Well, I mean, I'm not sure what that could mean, inference without evaluation. Do you have
For example, what I have in mind, what I have in mind is some sort of, well, for lack of, this isn't appropriate in this context, but something like a symbolic manipulation that would simplify it, some equivalence relation that would show that this, currently recursively defined thing is in fact equivalent to some other, visual, not symbolic, so obviously you're avoiding symbols, but some sort of other, so a set of visual manipulations, let's say, of the diagram that I would be allowed without evaluating to verify that they're valid.
Oh yeah, definitely. I understand now. So yeah, these entailments exist based on what you define and then what exists in logic, like, A entails A and A. So those, you can always pause the execution and work completely visually / symbolically to make simplifications or refinements. Yeah, you can apply the inferences without actually computing the results. Now I understand what you mean.
Yeah. And so you can do that because you understand it, but can it do it automatically? Is there a way, in other words, a higher level to it? Or do you envision the possibility of creating a higher level where it can have a database of operations, essentially, that it can do of transformations that have been allowed for some reason? Or
that definitely sounds useful. The question of how to bring automation into this is a big question. There's many ways that it could boost productivity. But again, just have to be careful how much you integrate it, because it could start to use just like tons of computing power and resources. But there definitely should be some like suggestions of inferences or entailments that could simplify something, but also like auto completion, like you say you select some subset of ports and it automatically makes like a new blank node with those ports and starts suggesting ways of connecting those. So that kind of thing could really help. And I do think logic programming is already pretty good at it. Yeah.
Thank you.
Yeah, good question.
I propose, we're at the hour here, so I propose we stop the live stream and then we can continue discussion as a group.
Cool. Yeah, were there any other questions from the YouTube?